to a YouTube lesson on series circuits. Now in this tutorial, we'll explore the fundamental concepts of series circuits, including their characteristics, the formula to calculate total resistance, and examples to calculate resistance in a series circuit. Now by the end of this video, you will have a solid understanding of series circuits and how to work them. Now the first thing that we'll be looking at is the characteristics of a series circuit. Now a series circuit is a type of electrical circuit in which components are connected end to end. So this is resistor 1, this has a positive side and a negative side, or it just has two terminals. And here we have resistor 2. Now the end to end here is when this end of the resistor is connected to the other end of the resistor, forming a single path for current to flow. Now in a series circuit, the same current flows through each component, meaning that if 2 amps is applied to the circuit, or the circuit is using 2 amps, therefore 2 amps will be flowing through this resistor as well as this resistor. Now the voltage across each component in a series circuit adds up to the total voltage of the circuit. Now if 5 volts is applied to the circuit, then depending on the resistance value of R1, then some voltage will drop across this resistor, and again depending on the resistance value of R2, then the remaining voltage value will be dropped across or will be used up by that resistor. Now the sorry thing about this series circuit is that if one component in the series circuit fails, then the entire circuit will be interrupted and no current will flow. What do I mean? If there's an opening here in this circuit, it means that the current will stop flowing, hence causing this resistor to stop work and this resistor to stop work. Now let us quickly look at the formula used to calculate resistors in series. So we have total resistance, to use RT, and please note that the T is smaller than the R, so the T is a subscript, which is equal to R1 plus R2 plus R3, and we can add as many resistors as needed, right? So the N represents any number or the amount of resistors that we need to add. Now, let us look at an example. Suppose we have a series circuit with 3 resistors where R1 is equal to 10 ohms, R2 is equal to 20 ohms, and R3 is equal to 30 ohms. Now we could represent this information in the circuit. So here we have R1, R2, and remember they are connected so that we have a single path for current to flow, and R3. So we have R1, R2, and R3. Now R1 is equal to 10 ohms, R2 is equal to 20 ohms, and R3 is equal to 30 ohms. So we write the formula. So RT is equal to R1, which is 10, R plus R2, which is 20, and R3, which is 30 ohms. Now RT is now equal to, so 10 plus 20 equals to 30, plus 30 will give us 60 ohms. So 3 resistors connected in series, and they are connected end to end, R1, R2 plus R3, and then you will get, so 10 plus 20 plus 30 will give us 60. Now let us look at another example. So R1 is equal to 15 ohms, R2 is equal to 25, and R3 is equal to 40 ohms. Now remember the formula. RT is equal to R1 plus R2 plus R3. And again, we could represent this by drawing the circuit. R1, R2, and R3. So now we have RT is equal to 15 ohms plus 25 ohms plus 40 ohms. What do you think the total resistance value will be? So we have 15 plus 25 will give us 40, plus 40 will give us 80. So the total resistance for this circuit is 80 ohms. Now remember that series circuits are essential components of electrical systems where the components are connected in a single path. One single path. Now, understanding the characteristics and the calculations of series circuit allows us to analyze and design various electrical systems effectively. Now, I hope you understood what was done here, and I just want to thank you very much for watching. Now, if you found this video helpful, please like, share, and subscribe for more tutorials on electrical circuits and other related topics. If you have any questions or suggestions for future videos, feel free to leave them in the comments below. Until next time, happy learning!